Okay, now this is factoring again. There's no equal sign. It's not set equal to 0, so we're not finding what those x values are, although I'll probably show you what you could do if you needed to. But there's going to be this new method. You'll end up using this in trig, probably calculus, and in other types of math. This leading term is x to the fourth. Then you've got an x squared, and then you've got a constant. So there's this one method. It's called the U-Substitution. The U-Substitution method. What that tells us, because we normally see x squared, normally we'd see this as x squared plus 6x plus 9, a regular quadratic, and we know what to do there. So we're going to work with that. So I'm going to say, all right, I'm going to let x squared equal to u. If I square the x squared, that's x to the fourth. So I would just square u, and that would be u squared. So now I can substitute. That's what's called U-substitution. X to the fourth, I'll substitute and say u squared plus 6x squared is now u. Well, now we've got a normal quadratic. So factors of 9 that add up to 6. Well, that's just be 3 and 3. So it's u plus 3. And since there's two of them the same, we can just say squared. So we can say, whoops, and remember, we're going to take the opposite of that, and we're going to say that's equal to negative 3. We're not done yet. Now we have to go back to the u substitution. What does u equal? Now we substitute x squared is equal to negative 3. Yikes. So to get the x squared by itself, let me move this over a little bit. We have to take, not only because this is a quadratic, we have to take both the positive and negative. Because there's a negative sign underneath, I'm going to rewrite that as negative 1 times 3. And then remember what the square root of negative 1 is? It's I, positive negative I. So this right here becomes positive negative I times the square root of 3. So x is equal to negative, and I'll rewrite it as root 3i and positive root 3i. Now, again, it didn't ask you to solve these, so I'm showing you the extra steps. So this is one method, and this is called the U-substitution method, that you always let the squared variable equal u, and then the squared variable squared is to the fourth power, so the u would be the second power. All right, I'm going to erase all of this, so if you need to pause it, go ahead and pause it, and I'm going to show you another method. So let me go ahead and make this easier. We're not going to do the U-substitution method now. So we can still do it the regular factoring method. So the factors of x to the fourth, x squared, x squared. Now, you're not going to want to do x to the third, x to the first. It will not end up working out. So when you have ones like this, when it factors, they need to have the same exponent. And then factors of 9 that add up to 6, factors of 9 that add up to 6. And again, we could have just, so there's going to be two of those, right? We're going to say this x squared plus 3 is equal to 0. And we're going, oh, and on that other one, I forgot to do the second set. There should have actually been 4 answers. So probably need to go back and fix that. Well, we only need to do this once, but there are multiplicities of 2 on both of those. So we're going to subtract 3. We're going to take the square root, positive, negative, and where that negative is, I'm going to rewrite that as -1 times 3, square root, and I comes out. Remember, each of these are going to have a multiplicity of 2. So this is negative root 3 times I with a multiplicity of 2, and positive root 3i with a multiplicity of 2. Now, if you want to graph that, I know it's going to cross here at 9. I don't know where else it might cross, but this is an x to the 4th. So it might look something like this. Because these 4 answers right here, because there's multiplicity of 2 twice, have to be represented. But the only thing we know for sure is where it touches the y-axis. All right, so that's it. Let's see. Yep, I think that's it for the U-substitution or factoring quadratics. If I come over here and we do it this method, and then factors of -72, that add up to that -1. So -9, positive 8. They multiply to be -72. They add to be -9, or they add to be -1. So x, this time you do have to set them both equal to 0 because of the x squared. You can't just take the opposite very easily. So we're going to add 9. So x squared is equal to 9. When we take the square root, we take the positive and negative. So -3, positive 3. This one's going to be trickier. We're going to subtract 8. So we've got x squared is equal, I'm going to say -1 times 8. When we take the square root, well, 8, I'm going to rewrite as 4 times 2, because 4 is a perfect square. So this -1 and I comes out. 4, square root of 4, a 2 comes out. So this x equals -2i, -2 root 2 times I, and positive 2 root 2 times I. Again, this is just if you're solving. All right, that's it for U-substitution, even though on these I showed the other method. I showed both. Sorry about that.